Next is example number 31. This we have to find the value of x, and the given values are sin inverse of 2a upon 1 plus a square plus cos inverse of 1 minus a square upon 1 plus a square is equals to tan inverse of 2x upon 1 minus x square, and x and a belongs to 0 to 1. So these are the given properties and we have to find the value of x. So here 2a upon 1 plus a square, 1 minus a square upon 1 plus a square are in this form, that is 2 tan theta upon 1 plus tan square theta and 1 minus tan square theta upon 1 plus tan square theta. So we will simply assume this a to be equals to tan theta. Now when this a is from 0 to 1, so 0 less than equals to a less than equals to 1, and since we assume this to be tan theta, so our tan theta will be 0 to 1. So theta belongs to 0 to pi by 4. Since this theta belongs to 0 to pi by 4, when we are drawing it on this unit circle, so this theta will be from this 0 to pi by 4, and since for sine inverse of x our required range will be from minus pi by 2 to pi by 2, and for cos inverse x our range will be from 0 to pi, that is this is 0 and this would be pi. So this theta that is from 0 to pi by 4, it is a subset actually. This 0 to pi by 4 belongs to this 0 to pi as well as minus pi by 2 to pi by 2. Hence in this condition, whenever we are requiring that sine inverse of sin x, we can write x as well as cos inverse of cos x is equals to x. Since this 0 to pi by 4, ultimately this tan theta is given and theta belongs to 0 to pi by 4. So this pi by 4, 0 to pi by 4 belongs to 0 to pi as well as minus pi by 2 to pi by 2, and ultimately when we will solve this problem, we can write sine inverse of whatever we are getting here, suppose sin x, then we can write sin x, and in place of cos inverse of x, cos inverse of cos x, we will write x. So here a equals to tan theta. Now placing this in this value, so this will be 2 tan theta upon 1 plus tan square theta, and this will be 1 minus tan square theta upon 1 plus tan square theta. So now placing these values, that is sine inverse of 2 tan theta upon 1 plus tan square theta will be equals to our sine 2 theta. So we will write it here sine 2 theta, and this 1 minus tan square theta upon 1 plus tan square theta will be cos 2 theta. So cos inverse of cos 2 theta is equals to tan inverse of 2x upon 1 minus x square. So sin inverse of sin 2 theta, that is 2 theta plus this is also 2 theta, is equals to tan inverse of 2x upon 1 minus x square. So this will be 2 into 2 theta is equals to tan inverse of 2x upon 1 minus x square. Now placing this theta, that is if a is equals to tan theta, then theta will be equals to tan inverse of a. So now replacing this theta with tan inverse a, so we will write 2 into 2 of tan inverse a is equals to tan inverse of 2x upon 1 minus x square. So on expanding this term, we will get 2 into 2 tan inverse A will be tan inverse A plus tan inverse A, that is tan inverse 2A upon 1 minus A square. This would be tan inverse of 2x 1 minus x square. Again, this is 2 into tan inverse of 2a upon 1 minus a square. So let us assume 2a 1 minus a square is equals to m. So this term will be 2 into tan inverse of m. So now it can be written like 2 tan inverse of m is equals to tan inverse of 2x upon 1 minus x square. So it will be tan inverse of 2m upon 1 minus m square equals to tan inverse of 2x upon 1 minus x square. Now placing 2a upon 1 minus x square in place of m, so we will get tan inverse of 2 into 2a upon 1 minus a square upon 1 minus 2a upon 1 minus a square whole square is equals to tan inverse of 2x upon 1 minus x square. So now on comparing this x and 2a upon 1 minus a square term, so finally we will get this value x equals to 2a upon 1 minus a square. Hence we can write x equals to 2a upon 1 minus a square, which is our required value. Next is example number 33. Here we have to find the value tan of 1 half of cos inverse of 2 upon under root 5 is given, and here hint is given, that is tan theta by 2 is equals to plus or minus under root of 1 minus cos theta upon 1 plus cos theta. So first of all, let us assume this 1 half cos inverse given, so already we have to assume tan theta by 2, so we will assume only this term. So cos inverse of 2 upon under root 5 is equals to theta. Hence cos theta is equals to 2 upon under root 5, which is greater than 0 value. Hence our theta will lie in this first quadrant, that is 0 to pi by 2, since cos theta is greater than 0. So when theta belongs to 0 to pi by 2, hence theta by 2 belongs to 0 to pi by 4. Hence theta by 2 will also have a positive value. Hence in place of tan theta by 2, it is plus or minus given, and now in our problem, in our solution, we will take only positive value. So writing this tan inverse of theta by 2, which will be equal to positive value, that is 1 minus cos theta upon 1 plus cos theta. In place of cos theta, we will write 2 upon under root 5. So it will be tan theta by 2 will be equals to 1 minus 2 upon under root 5 upon 1 plus 2 upon under root 5. So it will be under root 5 minus 2 upon under root 5 plus 2 whole under root. Now multiplying this numerator and denominator with this term, that is under root 5 minus 2. So we will get here under root 5 minus 2 whole square, and for this below term under root 5 plus 2 and under root 5 minus 2. So it will be 5 minus 2 square, that is 4. So ultimately we will get upon 5 minus 4 will be 1. So finally this value under root 5 minus 2 whole square and under root, hence it will become under root of under root 5 minus 2 whole square. So this square and under root will be cancelled, Hence our final value will be under root 5 minus 2, which is our required solution. Next is example number 34. In this, it is given mod of x is less than equals to 1, then the value of 2 tan inverse of x plus sin inverse of 2x upon 1 plus x square. So here it is in the form that is 2x upon 1 plus x square. So it is in this form, hence we will assume this x to be equals to tan theta. And since mod of x is less than or equals to 1, hence mod of tan theta will be less than or equals to 1. On removing this mod, we will get tan theta less than equals to plus or minus 1. So we can write it like minus 1 less than equals to tan theta less than equals to 1. Hence our tan theta lies between this minus 1 to 1. So our theta will lie between this minus pi by 4 to pi by 4. So 2 theta will belongs to minus pi by 2 to pi by 2. Why we are taking 2 theta? Because here 2x upon 1 plus x square is given. So somewhere we have to convert it in the sin 2 theta form. So since this 2 theta also belongs to minus pi by 2 to pi by 2, which is the range of sin inverse function. Hence at last we can write sin inverse of sin x is equals to x. So now solving this, that is 2 tan inverse x and x equals to tan theta. So it will be 2 tan inverse of tan theta plus sin inverse of 2 tan theta upon 1 plus tan square theta. So this will be tan inverse of tan theta, hence it will be 2 theta plus sin inverse of, in place of 2 tan theta plus 1 plus tan square theta, we will use this formula. So it will be sin 2 theta. So this is 2 theta plus sin inverse of sin theta will be theta. So it is 2 theta. Hence we can write 4 theta. And in place of, suppose theta, here x equals to tan theta, so theta will be tan inverse of x. So in place of 4 theta, we can write like 4 into tan inverse of x. Next is example number 36. This we have to find the number of real solution for the problem 1 plus cos 2x is equals to under root 2 of cos inverse of cos x in the range of pi by 2 to pi. So if we plot this on unit circle, we will get here pi by 2 and pi. And we know that this range of cos inverse x will be from 0 to pi, which is from this 0 to this pi. Hence this required interval belongs to 0 to pi. Hence pi by 2 to pi, which is given in our problem, belongs to this 0 to pi. So in such condition, we can write cos inverse of cos x equals to x. Now solving this left hand side, so we know cos 1 plus cos 2 theta is equals to 2 cos square theta. So writing this, we will get 2 cos square x is equals to under root 2 of, in place of cos inverse of cos x, since range is given pi by 2 to pi, hence we can write x. So this will be under root 2 of cos x is equals to under root 2 of x. So finally we will get cos x is equals to x. Now we are unable to solve this, so we will not get any real solution for our particular problem. Next is example number 37. This would be last example of objective type of question. In this, it is asked cos inverse of x is greater than sin inverse of x. Then we have to find the value of x. So we know that the range of cos inverse x is from 0 to pi and sin inverse x is from minus pi by 2 to pi by 2. Now in this problem we will use this equation, that is sin inverse x plus cos inverse x is equals to pi by 2. So here we will write cos inverse x in place of sin inverse x, we will write pi by 2 minus cos inverse x. So it will be 2 cos inverse x greater than pi by 2, hence cos inverse x will be greater than pi by 4. Hence our cos inverse x will lie greater than pi by 4 and less than or equals to pi. So we will write here cos inverse of x less than equals to pi. So it will be greater than pi and less than, it will be greater than pi by 4 and less than or equals to pi. Now applying this cos function, so when we are multiplying it with cos, suppose cos pi by 4, then since cos function is decreasing in first quadrant and our theta lies in this first quadrant, hence the sign gets reversed. So it will be cos pi by 4 cos inverse of x greater than equals to cos of pi. When we are applying this cos function in this first quadrant, cos is decreasing function, hence this sign gets reversed. So this will be 1 by root 2 greater than equals to x greater than equals to cos pi will be minus 1. Hence our value of x will be from minus 1 to 1 by 2, 1 by root 2.